So I guess I get to advance the charts here. Okay, my quick agenda. I won't dwell on this for very long. You can kind of see what we're going to talk about today. So as you know, GPS is a 24 satellite constellation in 6 planes. And we currently are flying those 12-hour orbits, semi-synchronous orbits, and in 24 primary slots. We're flying right now 7, what we call in our SPS specification, surplus satellites. So those are 7 satellites that are contributing that aren't part of those 24 slots. And you can kind of see across the 6 planes there on the bottom, you can see the 31 satellites that are represented, the 3 different blocks, the 2As, the 2Rs, and the 2RM satellites. Our control segment is represented here. Our master control station is there at Schriever Air Force Base in Colorado. The alternate is at Vandenberg Air Force Base. We do have 6 OCS, so that's operational control segment stations across the world, and 10 NGA sites that contribute to our monitoring. Those 10 NGA sites significantly contributed to the improvements that you're seeing across URE, which I'll talk about in a little bit. We do have 12 ground antennas, and 4 of those are GPS-only ground antennas. The other 8 are part of our Air Force satellite control network that are spread throughout the world. Oops. Go back one. Okay. In terms of our timing standard, we do currently have the requirement to keep GPS within 1 microsecond of UTC USNO. We significantly beat that requirement. Moving forward towards OCX, our requirement will be to keep it within 50 nanoseconds. You can see that we typically keep it within plus or minus 10 nanoseconds of UTC USNO. In terms of moving forward on the navigation message for the additional civil signals that we'll be adding, we do have the provision to carry the time offset between GPS and the other GNSS systems. Right now that we have the plans for Galileo and GLONASS, we do have we have space in our formatting to be able to add an additional 5 GNSS in that as well for the timing offset. In terms of the reference frame, our reference frame standards, we do use DE 200 currently for the planetary position. And moving forward for GPS-3 and OCX, the plan is to use the IERS Convention 2003. And our intent right now is to use the DE 405 ephemeris. And in terms of the geodetic model, we use WGS 84. And so the last update was there in 2004. The plan moving forward is an update in the 2010 timeframe for WGS 84. In terms of URE accuracy, this is a representation of what we are committed to providing versus what we are actually providing. And so we have some margin there. You can see the dramatic improvement over time of what we are actually delivering in terms of URE. And moving forward for GPS-3 and the next generation of our operational control segment, you can see that our required performance is significantly better than what we are committed to providing today. Mr. Shaw mentioned our GPS SPS performance standards, so our standard positioning system performance. You can see over time in the different columns there what the SPS spec has shown as our guaranteed delivered performance. And you can see the improvement over time. Our current SPS performance standard there in September of 2008, that was the most recently released one, and you can see the websites there where that specification is available. You can see also our performance in 2007 and how our performance significantly beat what we guaranteed in all aspects. And moving forward, we expect the same performance. The GPS signals that we have on the books today, so we know of our CA code and PY code. Currently, we're broadcasting M code and L2C on our 2RM satellites. Additionally, we will be fielding the L5 and L1C in the future generation of satellites, which you'll see in 1 minute. In terms of, and here they are, the Block 2As, of course, broadcasting the legacy signals, the 2RMs with added L2C and M code on L1 and L2. Additionally, we have one 2RM satellite, 2RM20, that has an L5 transponder on it, and that vehicle, as Dr. Parkinson mentioned, we do plan to launch in the March-April timeframe that will bring into use our L5 signal. Then the Block 2F will be delivered to the Cape sometime in the spring and launched in 2009, bringing in the next generation, bringing that L5 signal to fruition. Then the Block 3s in the 2014 timeframe will broadcast all the legacy signals and add a fourth civil signal, the L1C signal. And here we show the specifications for each of those signals, and I think the strength of these signals is in the public way that they were developed and in the public way that we make the specifications available. So these ICDs are free and available to download online. You can see the current versions that we have. We also have a public process by which we adjudicate comments for these documents. And so, I would encourage all of you, if you'd like to see any of the specifications, you can go to the website listed there and download the specifications. They are free and open. In terms of the deployment of the capabilities, you can see the L2C is of course going to be the first to have 24 satellites on orbit broadcasting the L2C. As was mentioned earlier, we currently today, the L2C signal does not have a navigation message being broadcast on it. However, in sometime this summer, we will begin broadcasting a subset of the navigation message we call the CNAV message that is outlined in our ICD, and it's the message type 0 for those of you who would like to go see that in the ICD. The 2F satellites and the 2RM, one version of the 2RM, will broadcast L5, and then you can see L1C being broadcast. It shows 2015 up there. Our current launch date for our GPS 3A satellites is in 2014, though. So with all that said, to continue on towards success for GPS, we will continue to have open specifications, open standards, a public process by which comments can be made to those standards. And Dr. Parkinson mentioned interchangeability on signals. We cannot have interchangeability on signals unless we have interoperable and compatible signals. You can't interchange them unless they're interoperable and compatible. So what we in the GPS community here in the United States are participating in multiple international forums like this one to ensure that compatibility and interoperability. And with that, I will conclude and let our next speaker come up.